Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is Physics 4024 of GCE, and today we are going to conduct lecture number 32. Yesterday we were talking about the energy, and we will continue that energy topic today, and hopefully we will conclude it today. Ladies and gentlemen, I told you yesterday that energy is the ability of a body to do work. Now, energies are available in different forms. Yesterday, we discussed that in greater detail as well. Today, a very important aspect of this energy topic is that energy can be converted from one form to another form. And you must have to keep in mind that the total energy will remain the same, and it cannot be neither destroyed nor it can be created. So that was the law of conservation of energy. Today our topic is interconversion of energy. So let us explain this topic with the help of few examples. You might have seen in the Olympics game or any world championship that a diver is diving on a springboard, and then he is performing somersault or different things inside that swimming pool. So let us consider that we are having chemical energy in our body, and with that chemical energy we are pressing the springboard with the help of our feet downward, and that energy from our body, which is in the form of chemical energy, is converted into the springboard in the form of gravitational potential energy, and as a result we press the springboard downward, and then when we press that downward, then the springboard is uh, pushing us against the great field force of gravity in upward direction, and that potential energy is then converted into kinetic energy, and we are then being able to perform different somersaults. So in this case, you saw that energy from chemical is converted into potential energy, and then potential energy is converted into kinetic energy. So that was one example of interconversion of energy. Let's take another example, and that is a cyclist going up to the top of a hill. Again, the energy stored in our body in the form of chemical is doing work against the gravitational potential energy, and we are riding to the top of the hill, uh, to the top of a mountain, and from the top if we are coming back, then that potential energy during the ride, which was stored as a gravitational potential energy, is now converted into kinetic energy, and the cycle is coming down without pushing the bicycle pedal. So it means that the potential energy is converted into kinetic energy. Another example is the burning of fuel such as oil, coal, or wood. For example, if we are putting oil inside our car tank, inside the oil there is a chemical energy. When the ignition switch of the car is turned on, it means that that chemical energy is converted into heat energy. Heat is a form of energy, so that energy is converted into heat energy, and that heat energy is pushing the car to move forward. That heat energy is then converted into kinetic energy, and that kinetic energy is doing work against the force of friction of the road, between the road and the tire of the car. So in this case, energy such as oil or coal in the railway, there are used coal, and that coal is producing heat energy when we are burning it, and as a result, the rail is moving forward due to that heat energy. And similarly, wood is also producing the, when you are burning it, it is producing heat energy. Stored inside the wood is the chemical energy, and that energy, when we are burning the wood, they are converted into heat energy, and we can take different types of works from that heat energy. The general purpose is to familiarize you people with the concept that energy can be converted from one form to another form. Let us talk another example, and that is connecting a battery to a filament lamp. Let me make the general diagram of a battery, and when there is a positive terminal and there is a negative terminal, we are connecting this battery to a filament lamp, and when the circuit is completed, it will turn on this filament lamp on. So this is a key. When key is pressed, then the electrons start moving. There is a motion, so there will be kinetic energy. From where that kinetic energy is coming, uh, that kinetic energy is stored in the battery in the form of chemical energy. Uh, in this battery, and that is moving from negative terminal to the positive terminal, and in conventional current from positive terminal to the negative terminal. We are not talking about that, but when the switch is closed, so it means this bulb will glow and electron will move. Who is pulling that, pushing that electron from negative terminal to the positive terminal? That is the acids available inside this battery, in which there is a chemical energy is stored. So that chemical energy is doing work on the electron to be driven inside this uh, copper wire, and as a result, it will glow this bulb due to current. What is current? The flow of electron. We will talk that about that in the electricity and magnetism, but for the time being, you have to understand that in this case chemical energy is converted into kinetic energy, which is converted into light energy and heat energy. Here there will be a light is also a form of energy, and there will be a heat due to the tungsten filament. It becomes very warm after few seconds. So that will release in the form of heat and light energy. Yes, so connecting a battery to a filament lamp is another example of converting one type of energy into different types of energies. Uh, the fifth example I am going to give it here is knocking a nail to a wooden block with a hammer. There is a nail and we are hitting it with the hammer. So, in our body, there is chemical energy, stored chemical energy in our body allow us to raise this hammer, and when we are raising the hammer it means that chemical energy is converted into potential energy because the height is increasing, and when we release that hammer, the potential energy is converted into kinetic energy. And when we hit the head of the nail, so this nail is doing work to be pierced inside the wooden block. And as a result, this kinetic energy is converted into sound energy and then heat energy between the head of the nail and the head of the hammer. So in this case also there is a mechanism of conversion of energy from one form into another form. Chemical energy, potential energy, kinetic energy, sound energy, and heat energy. So these sort of energies are used to be interconverted. The last example is interchange of kinetic energy and potential energy. Ladies and gentlemen, this is very important topic, and there is a bob pendulum system. When the bob connecting to a thread is at rest, it means that there is zero height with respect to the reference point. So it means there is uh, zero potential energy and zero kinetic energy. In our body, there is chemical energy, and we are dragging that from this central position to a position, which is the left extreme side of this whole system. So we are dragging it. It means that we are using our energy, chemical energy, and that will be converted into potential energy. At the top, at the maximum position, potential energy is maximum. Remember, because that is the maximum height. And here, because it is at rest momentarily, so kinetic energy will be zero. Kinetic energy will be zero, keep in mind, because potential energy depends totally on height, and here the height is maximum to this reference point, so it means it will have maximum potential energy. And when we release this potential energy, this bob, so it means the potential energy is somehow converted into kinetic energy. At this point, there will be potential energy and there will be kinetic energy. From where this kinetic energy came? And this is because there was maximum potential energy at height, and this potential energy is, for example, half converted into kinetic energy, but still there is a potential energy, and they are increasing the this is the increase of kinetic energy. Now, when it is moving further and reaching to the C central या mean position, here the potential energy will be zero, because we took this C as a reference point, and with that reference point it is at zero height. Here the kinetic energy will be maximum. Remember one important principle, that at maximum point potential energy is maximum, but at the mean position totally that potential energy is converted into kinetic energy. Here potential becomes zero and kinetic energy is now maximum. From where that kinetic energy came? That kinetic energy came from this potential energy. Now it is moving in upward direction. At point D there will be kinetic energy and there will be potential energy, but that will decrease both of them, the kinetic energy and the potential energy. Both of them will be decreased, because when it is going to the upward direction from this side it was increasing because they are pushing. So when they are going upward, force of gravity is there, and that force of gravity along with the friction is trying to reduce the motion of this bob. So at the middle point, this D, there will be kinetic energy and there will be potential energy, and the sum of that kinetic and potential energy will be equal to the sum here and the sum here and the sum here. That is why I told you that the total energy will remain the same. It can be converted from one form to another form, but it will remain the same. Now, when it is reaching the maximum point E on the other side, so it means that there will be a stoppage momentarily for a short interval of time, and the kinetic energy will become zero and the potential energy on the other side will become maximum. This is a general explanation. Let me give you a practical example of this. For example, the potential energy here is 10 joule and the kinetic energy, because 0, so it will be 0 joule. Now at this position some of the potential energy will be converted into kinetic energy, for example 5 joule, and this potential energy will also remain 5 joule, because when 5 is subtracted from this 10, so it will give you this. At this position the potential energy is 0 joule, and all the energy which was in the form of potential energy at the maximum point is now converted to the total energy, and that is 10 joule. In the other direction here potential energy will be 5 and kinetic energy will also be 5 joules each. So at the final position kinetic energy is 0 and potential energy will be 10 joule, because all the kinetic energy at the bottom is now converted to potential energy, because kinetic energy is converted to potential energy as a whole. So there is a very important derivation of it. Here the total energy is 10. Here the total energy is 10, and here the total energy is also 10, as we can see in this position the total energy. So energy is converting from one form, from potential energy to kinetic energy, but at each point, remember, during this to and fro motion, the total energy will remain constant. And you can see 10, 10, 10, 10, 10. Although it was a 10 here, but it becomes 5 here, and then it became 0 here. So from where that total energy went when potential energy was 10 joule at the top, and now it is 0, it is totally converted into kinetic energy, which is 10 joule. Okay, that was a very important topic of the interconversion of energy, that was related to the interconversion of energy. There is a work example 6.4. There is a work example 6.4. And remember, ladies and gentlemen, that I told you that, remember that at top there was potential energy and at the bottom potential energy was 0. At the top it was maximum. So here they are giving you an example. This is horizontal, and there is a 5-meter height of this system, which I am writing 5 meter. It is given in that example that it is 5 meter, and there is a block of wood which is sliding on this plane, and the total distance is in this case also 30 meter. Yes, this is the 30-meter distance. So remember, keeping in view this aspect, the question is saying that find the uh, what is the kinetic energy of the block at the bottom of the slope. So we have to find the kinetic energy of the block at the bottom of the slope, for example here. Now you have to consider totally this scenario of 5 meter and 30 meter, which is given above. Whenever the students are hearing about the kinetic energy, they are just using this formula, and they, when came across, when they are seeing that there is no mass given and there is no velocity given, how can we find the kinetic energy? So they are forgetting that we have to find the potential energy, and the potential energy at the top here we have to find, and for that data is available because mgh here the mass is given as 4 kilogram. Here the mass, which is equal to m, is equal to 4 kilogram, and G value is constant near the surface of the earth, which is equal to 10 meter per second square. H is also given as 5 meter. So potential energy is equal to mgh. Putting all these values 4 into 10 into 5, it will be given as 200. Yes, it will be 200 joule at the top, but they want us to find the kinetic energy at the bottom of this slope. So, as the potential energy at the top of the slope is 200 joule, so all the potential energy will be converted into kinetic energy at the bottom of the slope, the bottom of the slope. So, ladies and gentlemen, the kinetic energy, the kinetic energy at the bottom will also be 200 joule. As I told you that potential energy at the lower point is totally converted into kinetic energy. So when this type of scenario is given, then you can find, and you can find the converse as well. If they are saying that this is the mass and this is the velocity of a block at the bottom of this slope, this is the situation, and find the potential energy at the top of the slope. So then you can find the kinetic energy, and you can say because total kinetic energy is converted from potential energy, so at the top the potential energy was this one. So that was also a very important topic given to us. Now we are turning our focus to another very important topic, but before that, I have to erase the whiteboard. So let me make a space for this topic. I am stopping the video for a few seconds and then I will restart. Okay, ladies and gentlemen, let us talk about the efficiency, which is very important topic as far as in physics. When you are going to the higher classes, thermodynamics is a field of physics in which we deal constantly with this type of situations. So understand what is efficiency. But let me first give you an example and explain it. Ladies and gentlemen, the principle of conservation is saying that as much input you are giving to an engine of a car, that much will be the output. How I am saying this? I am saying this that there is energy here and that is totally converted here. Yani there was maximum potential energy and the potential energy becomes zero and the kinetic energy is yani total potential energy is converted into, which is here is an input to the bulb, and when it reaches the C point, so it means that total potential energy is converted to kinetic energy. So law of conservation of energy is suggesting whenever there is input, that total input will be converted to useful output energy. But practically, when we are observing, we are putting 1 liter of petrol in a motorcycle, and the company is claiming that it will move 70 kilometer for 1 liter. But when actually we are observing whatever input they are giving us, the output is not always equal to the input. So we are using a term which is called efficiency to tell the working condition of the engine. If an engine is more efficient, then it means that it will convert more input into more output. 100% conversion is not possible. Yes, absolutely, 100% is not possible, but to the maximum it will give you the output. So that is why we will use another term, efficient. If more output is given by a uh, engine, then we are saying this engine is efficient. And if less output is given, then we are saying that this engine is less efficient. So what is efficiency? The ratio of output to the input. How much output we are getting on giving how much out input. But if we want to find the percentage efficiency, then we have to multiply this with 100%. Let me give you an example and then we will finish this, because we are getting running out of time. So there is electricity generation station. Whatever input is given, about 70% of the input is lost, and we are getting only 30% of the useful energy per work. Whenever there is a loss of energy, so it will due to the fraction, it will be due to the resistance of wire, it will be due to the length of the wire. As much more length of the wire is there, then it will lose much of the energy. So in this case, 100% efficiency is not possible. This is a universal law, because if you are putting petrol of 1 liter, so it will have to overcome the heat. It will get out from the engine in the form of heat energy, and it will also has to overcome the frictional force between the wheels and the road. So it has to overcome these things as well. So much of the energy will be wasted on this situation. Ladies and gentlemen, efficiency is useful energy output divided by energy input, and then we are always finding efficiency in percentage. So you have to multiply it with 100%. Tomorrow we are heading towards another very important topic, and that is power. So stay tuned. If you haven't subscribed my channel, please subscribe it and press the bell icon. Thank you very much for watching. Allah Hafiz.